January 21, 1941. Consolidated Aircraft Corporation, San Diego, California. Charles Emil Sorensen stood on the factory floor, watching men work outdoors in the Southern California sun, attaching engines to B-24 Liberator bombers, one painstaking rivet at a time. The 60-year-old Ford production chief, Cast Iron Charlie, they called him, had built the world's first moving assembly line at Highland Park in 1913. He'd overseen the River Rouge complex, where 100,000 workers produced 10,000 cars daily. But what he witnessed that morning made his blood run cold. 7 B-24 bombers completed since contract signing. 3 delivered. 1 bomber per day when America needed 1 per hour. Sorensen pulled out a notepad and began sketching. By midnight, he would conceive the most audacious manufacturing challenge in human history. A factory that would build 67-foot-long, 18-ton, 4-engine bombers using automobile assembly line techniques. Engineers would call him insane. Aviation experts would publicly mock the plan. Congressional investigators would declare it impossible. In 28 months, Willow Run would prove them catastrophically wrong by producing 8,685 B-24 Liberators, more bombers than the entire German aircraft industry built in 1944. May 26, 1940. 90 million Americans gathered around radios for President Franklin D. Roosevelt's fireside chat. His words carried the weight of approaching catastrophe. Government must harness the efficient machinery of America's manufacturers to produce 50,000 combat aircraft over the next 12 months. 50,000 planes. The number exceeded every aircraft built in the United States since the Wright brothers' 1903 flight at Kitty Hawk. Aviation industry leaders considered it fantasy. America's entire aircraft manufacturing capacity in 1940 could produce perhaps 6,000 planes annually. And those were trainers and light fighters, not 4-engine strategic bombers. The mathematics of war had shifted beneath everyone's feet. Belgium fell in 18 days. Holland surrendered in 5. France, the world's largest land army, collapsed in 6 weeks. Nazi Germany demonstrated that industrial capacity, not just military strategy, would determine the war's outcome. Roosevelt's advisors calculated that defeating Germany required 12,000 heavy bombers capable of reaching Berlin from British bases. The B-17 Flying Fortress and B-24 Liberator represented America's aerial battleships. The B-24 specifications revealed the enormity of the challenge. Length, 67 feet, 4 inches. Wingspan, 110 feet. Weight, when fully loaded, 65,000 pounds. 4 Pratt & Whitney R1830 engines, each producing 1,200 horsepower. Crew of 10 men, 10 50-caliber machine guns. Maximum bomb load, 8,000 pounds. Range, 3,000 miles. The aircraft contained 450,000 individual parts, held together by 360,000 rivets in 550 different sizes. A 1940s automobile had 15,000 parts and weighed 3,000 pounds. The complexity ratio, 1 B-24 equaled 30 cars compressed into a flying machine that had to function flawlessly at 35,000 feet in sub-zero temperatures while being shot at. Consolidated Aircraft of San Diego held the B-24 contract. The company had produced 7 bombers by January 1941. Their method, craftsmen working outdoors, hand-fitting parts, spending hours positioning engines on temporary rigs. 1 bomber every 3 to 4 days under optimal conditions. At that rate, reaching 12,000 B-24s would require 95 years. The desperate arithmetic drove the Roosevelt administration to an unprecedented decision: transform the automobile industry, the largest manufacturing sector in America, into an aircraft production empire overnight. Detroit's automakers had mastered mass production of complex mechanical systems. Their assembly lines moved with ruthless efficiency. Their workers numbered in the hundreds of thousands. Their experience with steel, aluminum, engines, and precision manufacturing was unmatched. But cars and bombers existed in different universes of complexity. Dutch Kindleberger, president of North American Aviation, captured industry sentiment perfectly. You can't expect a blacksmith to make a watch overnight. That condescension would age poorly. Sorensen arrived in San Diego with Edsel Ford, Henry Ford's 47-year-old son and company president, in January 1941. The government had requested Ford build B-24 components, parts supplier status. Sorensen took one tour of Consolidated's factory and dismissed that notion entirely. "This is how you would have built Model Ns in 1906, he told colleagues. The comparison wasn't hyperbole. Consolidated's workers assembled bombers the way medieval craftsmen built cathedrals, one unique structure at a time, with parts that rarely fit without extensive hand-filing and adjustment." Sorensen watched welders work on fuselage sections. He observed riveters spending hours reaching difficult angles. He noted the lack of standardized tooling. He calculated the man-hours per bomber, approximately 225,000. Then he went back to his hotel room at the Coronado. Sleep proved impossible. His mind saw something the aviation industry couldn't. He pulled out hotel stationery and began sketching. First, break the B-24 into subassemblies: fuselage sections, wing assemblies, tail components, engine installations, landing gear systems. Second, manufacture each subassembly on dedicated production lines running parallel. Third, converge all subassemblies at precise intervals on a moving final assembly line. Fourth, build the tooling and fixtures that would make every B-24 identical to thousandths of an inch tolerances. The pencil sketch showed a factory 1 mile long and a quarter-mile wide, the largest single-story building ever constructed, an L-shaped design to avoid encroaching on the planned airport, assembly lines that would move continuously, feeding subassemblies into final production. One completed bomber rolling off the line every 63 minutes. At breakfast with Edsel Ford, Sorensen was exhausted but electric with possibility. "I can build one B-24 per hour," he said. Edsel studied the hotel stationery sketch. "How much will it cost?" $200 million. Edsel Ford didn't hesitate. "Let's do it." Back in San Diego, Sorensen met with Reuben Fleet, Consolidated's founder. Fleet listened to the proposal with barely concealed contempt. "Impossible," Fleet declared. "Aircraft aren't automobiles. The B-24 requires constant design modifications based on combat experience. Your mass production methods will produce obsolete aircraft." Sorensen's response changed history. "We're not interested in building subassemblies for you to assemble. Ford will build complete bombers or nothing." Fleet laughed. Army Air Corps representatives were present. They weren't laughing. They'd watched Consolidated produce 7 bombers in 8 months. They needed thousands. Immediately. 2 weeks later, contracts were signed. $200 million from the federal government. Ford Motor Company would design, build, and operate the world's largest aircraft factory. Construction would begin in April 1941. First bomber delivery, September 1942. Target production rate, 400 bombers per month by mid-1943. Critics emerged immediately. "Will it run?" became the project's mocking nickname. Congressional skeptics demanded oversight. Aviation industry veterans predicted catastrophic failure. The Air Corps hedged its bets by expanding B-24 production at multiple sites. Consolidated's Fort Worth plant, Douglas Aircraft in Tulsa, North American in Dallas. Ford's gamble would either revolutionize aircraft manufacturing or become the most expensive industrial failure in history. April 1941. Willow Run Creek, Ypsilanti, Michigan. 975 acres of Henry Ford's farmland, 25 miles west of Detroit. 5 construction firms descended on the property simultaneously. Albert Kahn, the industrial architect who had designed Detroit's automotive palaces, translated Sorensen's hotel stationery sketch into engineering reality. 3.5 million square feet of floor space. Assembly line 1,600 feet long. Ceiling height 26 feet to accommodate vertical assembly of tail sections. 4 massive turntables positioned 2/3 along the assembly line to execute the 90-degree turn. The logistics dwarfed anything previously attempted. 35,000 tons of structural steel, 5 million bricks, 650,000 square feet of glass, 27 miles of underground utility tunnels, 136 separate conveyor systems powered by 75 drive units. Construction proceeded 24 hours daily. Workers used plywood partitions to seal completed sections from areas still under construction. Production began in partially finished buildings, while construction crews completed other sections. By September 1941, the first production equipment arrived. November 1941, the plant was officially dedicated. Major Jimmy Doolittle attended the ceremony. Charles Sorensen made his infamous public commitment: 1 B-24 every hour. The aviation press printed the quote beneath photos of Sorensen, often with barely disguised mockery. But the real challenge had only just begun. Sorensen's engineers arrived in San Diego to obtain B-24 blueprints. What they found represented their first crisis. Consolidated's engineering drawings were incomplete, inconsistent, and often contradictory. Symbols and measurements used non-standard notation. Critical dimensions existed only in the memories of senior foremen. Drawings that did exist frequently showed parts that didn't match the actual aircraft. Sorensen's solution bordered on obsessive. He ordered 2 complete B-24s flown to Dearborn and disassembled. Every rivet removed, every part catalogued, every dimension measured. A 1,000-member tool design team worked 7 days a week in rotating shifts for 11 months. They reverse-engineered the entire aircraft. They created 3-dimensional schematics of 30,000 separate components. They generated 5 million square feet of new blueprints. Every part had to be documented with precision that allowed mass production. Casting molds required tolerances to thousandths of an inch. Stamping dies needed to produce identical parts, regardless of which shift operated the press. Fixtures, some standing 60 feet tall, had to position components perfectly for robotic precision riveting. The team designed 1,600 custom machine tools. They created 11,000 specialized fixtures. They mapped assembly sequences that would move 450,000 parts through 69 sub-assembly stations before converging into 11 major assemblies that would finally become one bomber. The engineering achievement was staggering, but engineering alone wouldn't build bombers. Ford needed workers. 42,000 workers at peak employment. The largest concentrated manufacturing workforce in Michigan. But where would they come from? Young men were joining the military by the hundreds of thousands. Skilled automotive workers had their choice of defense jobs in Detroit, much closer to home. Willow Run sat in farmland, accessible only by a 2-lane road. No housing existed within 15 miles. No public transportation served the area. The federal government stepped in with housing projects. Willow Run Lodge, dormitories accommodating 3,000 single workers. Willow Run Village, 2,500 family housing units constructed on farmland purchased from Henry Ford. 30 additional dormitories, 6 community buildings. Police and fire stations, schools for workers' children, 1,000 trailer homes. An entire city built from nothing in 18 months. Transportation remained critical. Ford and the government established bus lines. Fleets of buses ran 24-hour schedules between Detroit and Willow Run. Workers endured commutes of 90 minutes each way. Some slept 4 hours, worked 9, commuted 3, slept 4 more, returned. The workforce demographics shifted as the war progressed. Initial hiring focused on experienced automotive workers. By 1942, those men were entering military service. Ford faced a choice: fail to meet production quotas or revolutionize hiring practices. Women entered the factory in unprecedented numbers, 15% of the workforce by May 1942, one-third by peak production in 1944. 12,000 women working as riveters, welders, crane operators, inspectors. Equal pay, 85 cents per hour, regardless of gender. Roswell Monroe, a riveter from Pulaski County, Kentucky, became the most famous. Hollywood producers filming a war bonds promotion noticed her working inside a B-24 fuselage. Her image became the Rosie the Riveter poster, the muscle-flexing woman declaring, "We can do it." But Rose was one of thousands. Women named Lorraine, Mally, Phyllis, Rachel May, Mary Jane, Marge. They crawled into bomber wings to hold rivets. They operated 60-foot-tall stamping presses. They welded aluminum skin onto fuselage frames. They did it while their husbands, brothers, and sons fought overseas. African Americans comprised significant percentages of the workforce, unusual for 1940s Detroit. Henry Ford had maintained progressive hiring policies regarding black workers. Willow Run continued that practice out of necessity and principle. The plant even employed workers of short stature for specialized roles. Some areas inside B-24 wings measured less than 18 inches in diameter. Standard-sized workers couldn't reach critical rivet positions. Ford hired people small enough to crawl into wing spaces and hold bucking bars against rivets from the interior, while riveters worked from the exterior. The workforce's diversity became a symbol of American capability. When victory depended on it, prejudices became unaffordable luxuries. But even with workers, housing, and transportation solved, Willow Run faced its gravest challenge: actually building bombers. September 1942, the first Ford-built B-24E rolled off the Willow Run line. Photographers captured the moment. Newspapers published celebratory articles. Behind the scenes, Ford engineers knew the truth. The aircraft had problems. Serious problems. Fuel leaks appeared throughout the system. Ford couldn't replicate Consolidated's proprietary heat treatment process for aluminum fuel tank seals. The government forced Consolidated to share the technique, but Ford's implementation failed repeatedly. Planes leaked fuel, reducing range and creating fire hazards. Rivet patterns didn't match Consolidated standards. Ford's automated riveters worked too fast, occasionally cracking aluminum skin. Manual inspection and repair became necessary for every aircraft. October 1942, 1 bomber produced. November 1942, 2 bombers. December 1942, 3 bombers. The congressional critics descended with vengeance. Senator Harry S. Truman's committee investigating defense production focused extensively on Willow Run. Their February 1943 report was damning. Ford Motor Company has created a production line that too closely resembles an automobile assembly line, despite the warning of many experienced aircraft men. The criticism contained elements of truth. Ford had assumed aircraft parts could achieve the same tolerances as automotive parts. They couldn't. Aircraft operated in environments cars never experienced. Minus 60 degrees Fahrenheit at 35,000 feet. Rapid pressure changes, extreme vibration from 4 massive engines. Combat damage that required parts to maintain structural integrity even when compromised. The Air Corps issued constant design changes based on combat experience. Improved gun turrets, modified bomb release mechanisms, enhanced defensive armor, better oxygen systems, radio equipment upgrades. Each change disrupted Ford's assembly line. New tooling required, new part specifications, new inspection procedures, new worker training. Mass production demanded standardization. Aircraft combat evolution demanded constant modification. The contradiction seemed insurmountable. Sorensen protested to the Air Corps, "Stop changing the design or we'll never reach volume production." The Air Corps response, "Build better planes or we'll give the contract to someone else." Ford's solution required complete organizational restructuring. Meade L. Bricker replaced Sorensen as plant manager in autumn 1943. Ford decentralized production, sending sub-assembly manufacturing to nearly 1,000 suppliers. Willow Run concentrated on final assembly. The plant established modification centers where aircraft received updates after rolling off the line but before delivery. Design changes were batched into quarterly updates rather than continuous revisions. Workers received intensive retraining every 90 days. Quality inspectors numbered in the hundreds, far exceeding automotive standards. Every bomber underwent complete systems testing before leaving the facility. The 1,384-acre airport adjacent to the plant included 3 hangars. The largest could house 20 B-24s simultaneously. Test pilots flew every bomber before acceptance, engine performance, flight control responsiveness, pressurization systems, defensive armament. Pilots and crews slept on 1,300 cots while waiting for aircraft to complete testing. An on-site hospital employed 8 doctors, 40 nurses, and a dentist. It treated more than 2 million medical cases during the war. Remarkably, 0 fatalities recorded at the facility during operation. 24 lunchrooms throughout the complex. The plant kitchen produced 10,000 fresh rolls daily. Lunch wagons traveled the factory floor, serving meals to workers who couldn't leave their stations. The facility became a self-contained industrial city operating continuously. 2 9-hour shifts, 4 hours between shifts for restocking parts and changing tooling, 6 days per week, 24 hours per day, and gradually, painfully, production accelerated. January 1943, 31 bombers. February 1943, 75 bombers. March 1943, 104 bombers. The learning curve was vicious but real. Worker experience accumulated, assembly procedures refined, quality improved, speed increased. April 1943, 150 bombers. May 1943, 184 bombers. Then came the breakthrough, the center wing assembly. The massive spar that connected both wings to the fuselage represented the critical bottleneck. Early production required 13 days per wing section. Ford's engineers developed a multi-function machine that completed 42 precision machining operations to 2 10,000ths of an inch tolerance in 17 minutes. Wing production time, 13 days reduced to 1 hour. That single innovation cascaded through the entire system. Wing sections arrived at final assembly just as fuselage frames reached the convergence point. Tail assemblies met their scheduled positions. Engine installations synchronized perfectly. The moving assembly line began to move. January 1944, 298 bombers. February 1944, 312 bombers. March 1944, 367 bombers. April 1944, 453 bombers in 468 hours. 1 B-24 Liberator every 63 minutes, exactly as Sorensen had promised 3 years earlier. The impossible became routine. The production data revealed American industrial might in stark mathematical terms. Willow Run in 1944, 453 bombers per month. All of Consolidated Aircraft combined, 350 bombers per month. Douglas Tulsa, 225 bombers per month. North American Dallas, 175 bombers per month. Ford alone produced more B-24s than the next 3 manufacturers combined. Peak monthly capability, 650 bombers. The Air Corps actually ordered Ford to slow production. We have no place to park them, officers admitted. Combat losses haven't reached projected levels. The mathematics of air superiority had shifted decisively. Germany's entire aircraft industry produced 39,807 planes in 1944. Willow Run alone built 4,176 bombers that year. One factory in Michigan outproduced entire German industrial sectors. Cost per aircraft told an equally devastating story. B-24 cost in 1942 $304,391. B-24 cost in 1944 $215,000. Some sources reported $124,516. Ford's mass production reduced unit costs by 40 to 60% while improving quality. The B-17 Flying Fortress cost $187,000 per aircraft but carried less bomb load, flew shorter ranges, and had inferior ceiling performance. The B-24's complexity premium vanished under mass production efficiency. Man-hours per bomber at consolidated San Diego, 24,800 hours in January 1943. Man-hours per bomber at Willow Run, 40,500 hours by January 1944. Ford's assembly line achieved 70% greater efficiency than traditional aircraft manufacturing. The strategic impact became undeniable. 8,685 complete B-24s built at Willow Run. 1,193 additional knockdown kits shipped to Fort Worth and Tulsa for final assembly. Total Ford-attributed production, 10,578 aircraft. Ford built more than half of all B-24 Liberators ever manufactured. The B-24 became the most produced American military aircraft in history. Total production across all plants, 18,493 bombers. Those aircraft dropped more than 635,000 tons of bombs on Axis targets. They flew millions of combat hours. They closed the Atlantic Gap where U-boats had operated with impunity. They hammered Ploesti's oil refineries. They supported D-Day operations. They ranged across the Pacific from island to island. But the human cost behind those statistics deserves recognition. B-24 crews faced 50% casualty rates on some missions. The aircraft's high-mounted wings made crash landings catastrophic. Fuel system vulnerabilities created fire risks. The aircraft was difficult to fly, especially in formation at altitude. Pilots needed maximum strength and skill to control it. General Hap Arnold, Air Corps Chief, told consultant Charles Lindbergh that combat squadrons preferred the B-17, because when we send the 17s out on a mission, most of them return, but when we send the 24s out, most of them don't. Yet the B-24 remained essential because its range and payload exceeded the B-17's capabilities. Strategic bombing doctrine required deep strikes into enemy territory. Only the B-24 could reach distant targets and return. By 1945, technological progress rendered even the revolutionary B-24 obsolescent. The B-29 Superfortress offered pressurized cabins, longer range, higher ceilings, and heavier bomb loads. B-29 production shifted to different factories. Willow Run's contract was officially terminated May 31, 1945. The final B-24 rolled off the line June 28, 1945. World War II ended 2 months later. Total production statistics revealed industrial achievement on unprecedented scales. 92 million pounds of aircraft produced at Willow Run. More than Germany's entire airframe production in 1944. 4 American plants, Ford Willow Run, Boeing Seattle, Consolidated San Diego, Douglas Long Beach, each individually exceeded Germany's total national output. The comparison wasn't close, it was civilizational. The men and women who built those bombers changed history. They worked 9-hour shifts in deafening factory noise. They handled razor-sharp aluminum skin that could slice fingers to bone. They breathed metal dust and chemical fumes. They operated machinery that could crush limbs if safety protocols lapsed. They did it for wages between 85 cents and $1.20 per hour. They did it because victory required it. Edsel Ford never witnessed Willow Run reach its potential. Stomach cancer killed him May 26, 1943, at age 49. Stress from the B-24 project undoubtedly contributed to his declining health. He spent the final months of his life fighting to make the factory succeed against congressional criticism and public doubt. His father, Henry Ford, watched the empire he built teeter toward collapse as age and poor health diminished his capacity. His grandson, Henry Ford II, was released from naval service in August 1943 to help stabilize the company. The internal Ford family drama played out against Willow Run's transformation from mockery to miracle. Charles Sorensen resigned under pressure in 1944. Internal politics and conflicts with Harry Bennett, Henry Ford's notorious security chief, made his position untenable. He never received full credit for conceiving and executing the most ambitious manufacturing project in history. The workers themselves fared better than the executives. Many of the Rosies returned to domestic life after the war. Many did not. They'd proven they could perform men's work. They'd earned paychecks for the first time. They'd gained economic independence. Some used GI Bill education benefits. Women's auxiliary services counted as military service. Some became engineers, teachers, business owners. They passed different expectations to their daughters. The social transformation matched the industrial achievement. Willow Run itself transitioned through multiple post-war incarnations. Kaiser Frazer Corporation produced automobiles there, 1947, 1953. General Motors leased and then purchased the facility after a 1953 fire destroyed their transmission plant. GM produced Corvairs, Novas, and eventually powertrains and transmissions. The plant closed in 2010 during GM's bankruptcy. Most of the massive structure was demolished in 2014. A 175,000 square foot section was preserved and became the Yankee Air Museum. The American Center for Mobility now operates an autonomous vehicle testing facility on the remaining grounds. The physical plant is gone, but its legacy persists. Willow Run proved that complex aircraft could be mass-produced using automotive techniques. Post-war commercial aviation adopted Ford's methods. Boeing's 707, Douglas's DC-8, and every commercial aircraft since owe conceptual debt to Sorensen's hotel stationery sketch. The factory demonstrated that impossible production targets become achievable through systematic deconstruction of problems into manageable sub-assemblies. Modern aerospace manufacturing, whether Boeing, Airbus, Lockheed Martin, or SpaceX, follows Willow Run's architectural principles. Build components in parallel, converge on moving assembly lines, standardize tolerances, automate repetitive operations, train workers systematically, inspect comprehensively. But perhaps the most profound legacy exists in organizational capability. America in 1940 couldn't build 50,000 aircraft annually. By 1944, America produced 96,318 aircraft. That transformation didn't occur because American workers suddenly became better than German or Japanese workers. It occurred because American industry systematically solved manufacturing problems at scales others couldn't imagine. Ford transformed car factories into bomber plants not overnight, but through 28 months of relentless problem-solving, crisis management, and organizational learning. The achievement required vision. Sorensen's sketch. Capital, $200 million in 1940s dollars, equivalent to $4.2 billion today. Political will. Roosevelt's commitment despite congressional criticism. Engineering brilliance. Reverse engineering 30,000 components. Workforce mobilization, 42,000 workers relocated and trained. Infrastructure creation, housing, transportation, medical care, food service. Manufacturing innovation, custom tooling, precision fixtures, quality control systems. Every element had to function simultaneously. Remove any single component and the entire system fails. That coordination, that organizational orchestration, represented American industrial capitalism's greatest achievement. Private enterprise executing public purpose. Market efficiency directed toward national survival. Innovation motivated by existential necessity. The German war economy never achieved comparable coordination. Nazi ideology prevented mobilizing women into industrial work until too late. Hitler's interference disrupted production planning. Allied bombing destroyed factories faster than they could rebuild. Resource shortages, oil, aluminum, rubber, constrained output. Slave labor proved inefficient compared to motivated free workers. German aircraft production in 1944, 39,807 planes. American aircraft production in 1944, 96,318 planes. The gap represented not just industrial capacity, but systemic organizational superiority. Japan faced even starker limitations. Limited resource base, smaller industrial capacity, geographic dispersion across islands, American submarines interdicting supply lines. Japanese aircraft production peaked at 28,180 planes in 1944, impressive for their constraints, but insufficient against American output. The arithmetic of war became a mathematical certainty. 3 American factories outproduced the entire Axis combined. American crews flew American planes built by American workers, using American materials extracted from American resources. The logistics of total war favored the nation with continental resources, oceanic protection, and industrial infrastructure untouched by enemy bombs. But statistics alone don't capture what Willow Run meant to the workers who lived it. Rose Monroe described meeting her husband at the plant. "We worked in the same department, corresponded all during the war, got married after." She worked from the 36th B-24 through the 8,785th. 9-hour shifts, 6 days weekly for 3 years. Marge Walters remembered the pressure. "Our boss was rough on us. Come on, we gotta get this done. Come on, we gotta get this done." She worked until exhaustion became routine. "We just really worked hard." Mary Jane Childers sat inside bombers, holding bucking bars against rivets while Rose worked from above. "We changed places every 2 hours to prevent muscle damage." The physical strain was immense, holding metal bars overhead for hours while vibration from pneumatic riveters rattled bones. Rachel May Perry worked through measles. "I told the boss if he didn't get away and leave me alone, I'd give him the measles too." These weren't abstract historical figures. They were real women with names, personalities, and memories. They shaped history with their hands. The center wing section Marge Walters worked on is flying in someone's bomber. Preserved in a museum, perhaps, or rusting in a boneyard. The rivets Rose Monroe set hold aluminum skin together 7 decades later. The welds, the inspections, the quality control checks, all performed by people who knew their work, determined whether crews lived or died. That knowledge created quality standards beyond mere specification compliance. Workers understood. Sloppy rivets meant fuel leaks, meant fire, meant 10 men burning to death at 35,000 feet. Every rivet mattered, every weld counted, every inspection was life or death. The on-site hospital's 0 fatality record during wartime production represented extraordinary safety consciousness. Willow Run operated massive machinery 24 hours daily for nearly 4 years. 42,000 workers rotated through shifts. Massive stamping presses, moving conveyor systems, overhead cranes, welding equipment, riveting guns. Industrial accidents were common in 1940s manufacturing, yet Willow Run maintained safety protocols that prevented deaths despite the pressure for speed. That achievement deserved recognition equal to production statistics. The factory's closure in 2010 sparked preservation battles. Veterans organizations and history advocates fought to save the building. The Save the Willow Run bomber plant campaign needed $8 million. They were $1 million short as the deadline approached. A 92-year-old woman from Monroe, Michigan, sent $10, her Social Security check total for the month. Her note read, "This is all the money I can afford, but I want you to have it, because what you're doing saving this history, which is my history, is so important." That $10 donation represented more than financial contribution. It symbolized recognition that what happened at Willow Run changed America, changed the world, changed expectations about what manufacturing could achieve. The museum that now occupies part of the original facility displays photographs of workers. Videos play testimony from surviving Rosies. Visitors can see a partial B-24 fuselage, touch the aluminum skin, feel the rivets, understand the craftsmanship, but they can't feel the factory floor vibrating from 136 conveyor systems, can't hear the deafening roar of pneumatic tools echoing off 3.5 million square feet of enclosed space, can't smell the metal dust and hydraulic fluid, can't experience the exhaustion of 9-hour shifts repeated 6 days weekly for years. The museum preserves artifacts. The reality is gone forever. What remains is the legacy. When people say American manufacturing built the arsenal of democracy, they mean Willow Run. When economists analyze rapid industrial mobilization, they study Willow Run. When engineers design modern assembly systems, they reference Willow Run. The factory proved that vision, capital, organization, and determination could achieve impossibility. Sorensen's hotel stationery sketch became 8,685 bombers. The mockery, "Will it run?" became vindication. The skepticism, "Blacksmiths making watches," became embarrassment. The criticism, "Too much like an automobile factory," became the exact reason it succeeded. Ford didn't turn car factories into bomber plants overnight. They turned a car factory mindset into bomber production through systematic engineering, organizational learning, crisis adaptation, and human determination. The timeline required 28 months from groundbreaking to peak production. The investment demanded $200 million and 42,000 workers. The casualties included Edsel Ford's life and Charles Sorensen's career. The victory produced 8,185 reasons the Axis lost the war. Those reasons flew across the Atlantic to bomb Berlin. They hunted U-boats across the ocean depths. They destroyed Ploesti's oil refineries. They supported D-Day from the air. They island-hopped across the Pacific. And every one of them, every single B-24 that rolled off the Willow Run line, existed because one 60-year-old production manager looked at an impossible problem and decided it wasn't. Charles Sorensen died in 1968 at age 87. Roswell Monroe died in 1997 at age 77, having worked as a riveter, pilot, and construction company owner. Willow Run closed in 2010. The preserved museum section reopened in 2017. The bombers are gone, scrapped, crashed, rusted, or museum pieces. The workers are gone, passed into history, their names recorded but their exhaustion forgotten. The factory is gone, demolished except for memories and museum fragments. What persists is the proof. America could build anything when survival demanded it. Industrial democracy outproduced fascist efficiency. Free workers outperformed slave labor. Mass production defeated craftsmanship. Organization conquered impossibility. Willow Run wasn't just about building bombers, it was about discovering what becomes possible when a nation commits everything to victory. And when that commitment met American industrial capacity, even the impossible became routine. One B-24 Liberator every 63 minutes. Just like Sorensen promised, on hotel stationery, after one sleepless night in San Diego, in San Diego, in San Diego, in San Diego, in San Diego.